Okay, this is where I left out last time, so I thought I will continue from here. Something was going wrong with my pen, so we're trying to solve this. If you look at it, square root of 20 is approximately 4.47. Square root of 20 plus square root of 20, this expression is 4.9 something, and then it gives 4.99. If you see, it's getting closer and closer to 5. So that means we can show that this whole expression is equal to 5. So how do we do that? If you let x equals this, if you see the inside expression is exactly the same. So you can write x equals square root of 20 plus x. So if you square both sides, you get x squared equals 20 plus x. So this becomes a quadratic in x, and the numbers of, the value of x that solves this is x equals 5 or negative 4. And it cannot be negative 4, so we are looking for the number 5 as the solution. So that's what we expected. There are equal number of pennies, nickels, dimes, and quarters in a bag. 4 coins are pulled out, one at a time, and each coin is replaced before the next is drawn. What is the probability that the total value of 4 coins will be less than 20 cents? 4 coins. So can there be 2 dimes? No, I don't think so. There can only be 1 dime, I think, because it has to be less than 20, right? So let's see how to do it. Because there are equal number of each type of coin, and the probability of drawing any one in a single draw is 1/4. Because the coins are replaced each time after you pick, you're not keeping it to yourself, right? You're putting it back. So the probability is 1/4, and it remains 1/4. So how many possibilities are there? 4 times 4 times 4, because there are 4 draws, right? 256. So each particular outcome has 1 over 256. The combinations, okay, so let's go into the detail. These are, okay, there is only one, okay, let's say there are 4 pennies. So this is only one way, right? P, 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 P. How about 1 nickel and 3 pennies? The number of ways to get this outcome is the number of permutations of n, 1 nickel, n, and 3 pennies. So it's 4 factorial over 3 factorial. 2 nickels and 2 pennies, n, and pp. So it's 4 factorial over 2 factorial times 2 factorial. Remember there's 2 n's and 2 p's. That's why you have to divide by 2 factorial 2 times. How about 3 nickels and 1 penny? Same thing as 3 pennies, 1 nickel, right? 4 factorial over 3 factorial. Okay, 3 nickels make 15. I cannot have 4 nickels. So 3 nickels is the limit. But I can have 1 nickel, 1 dime, and 2 pennies. So I have 1 nickel and 1 dime is 15, plus 2 is 17. So I have NDPP. So it's 4 factorial still, because there are 4, and 2 factorial divided by that. So 12. How about 1 dime? If I have 1 dime, 10, I can only have 3 pennies, right? We already covered 1 dime and 1 nickel. So the only other way is 3 pennies. So D and 3p, so 4. So how many are there? 4, 12, 4, 6, 4. So 10, 14, 26, 4, 30. And plus 1, all pennies, right? 31. So it's going to be 31 over 256. So if you go systematically, if you do it systematically, then you can, probability questions are okay. But sometimes it's hard. Probability questions could get, easily get into the wrong answers. Okay, the arithmetic mean of 10 consecutive even integers. Remember, 10 consecutive even integers is 3. What is the least of 3? Least of these 10 even integers. Because the mean is 3, half of them has to be less than that, half of to be more than that. So because the mean is 3, the 5 numbers that are less than 3 are -6, -4, -2, 0, and 2. Why is it? Because they are consecutive even integers. -6 is even. It's on the negative side. The next even consecutive is -4. The next is -2. The next is 0. The next is 2. So there are 5 on the left of 3. What are the 5 on the right of 3? 4, 6, 8, 10, 12, right? So what is the least? -6. So that's that. Let's take a look. This is a tricky question. In the figure shown, arc ADB and arc BEC are semicircles, each with a radius of 1 unit. Point DEF are the midpoints of arc ADB and BEC and arc DFE respectively. If arc DFE is also a semicircle, what is the area of the shaded region? So one of the tricky part about geometry questions is construction. What happens if I join BD and BE? If I join BD and BE, if you look at this part is same as this part is same as this part, right? Whatever the the portion of the semicircle is missing is this part. So that means the area of square happens to be the area of the shaded region we are looking for. But what is the area of the square? We don't know yet, right? Okay, in order to find the area of the square, what is the diagonal? What is the BF? We know that if we connect D and E, okay, let me show you this. If I have, there is one, not a very good diagram, but then you'll get the point. So if you connect this, that is 1, and if you connect this, that distance is 1. So if you go back to that picture, I cannot draw on that picture because it's a PDF, but I can show you. So this distance, if you connect this distance, DE, and if you draw a line, vertical line, that is 1 because it's a semicircle of a unit. And from that point onwards, because from here it's 1, so the total distance BF is 2. So that means the diagonal of the square is 2, right? So if the diagonal of square is 2, what's the area? So if you have the diagonal is 2, if the length of the square is x, so we know that the diagonal is the square root of 2x, square root of 2x, and that happens to be 2. That means x is 2 over square root of 2, which is square root of 2. So what's the area of the square? X square, right? And x square happens to be 2. So that's the area of the square. 2 is the area of the square, and that's the area of the shaded region. Okay, what I will do is I will leave the 9th and 10th questions for you to read because I have to quickly make these videos and put it for you to access, and we'll go from there.